Hello everyone. So today we are going to solve this path sum 2 problem. Okay, and I will try to solve it while explaining. Okay, so this is also my first time solving this problem. So let's get started. Okay, so the problem says that we have been given a root of a binary tree and an integer target sum. Okay, return all the root leaves path where the sum of the node values of the in the path equals to the target sum. Each path should be returned as a list of node values, not node references. Okay, a root leaf path is path starting from root and ending at any leaf node. A leaf is a node with no children. Okay, so basically what we have to do, okay, so let's take an example. Okay, so we have something like, okay, so I've been provided with the root, right? And so we have to return all the path from the root, right, to a leaf node. Basically, let's say we are considering this path. So if this target is equal to 22, right, 5 4 11 2, then we have to return this. Otherwise we can also return 5 8 4 5, and 5 8 4 1 does not adds up to 22. So if I have understood the question properly, then we should return 5 8 4 5, not 5 8 4 1, right? And obviously we must include the leaf node. Okay, each path should be written as a list. Okay, all the root leaf. Okay, so path should be written in which form? Let's say, okay, it's like we have to return only the values, node values. Okay, so for example, in this target is 1 3, so we have 5, right? And there is a possibility that what can be the possibility. So basically we can say that obviously no possible values, right? No possible values. So in that case, if there are no possible values, like we can see 1 2 3, so we have target sum as 5, but there are nothing from 1. We cannot, if we go to 3 or 2, we cannot get 5, right? In that case we should return uh, empty, right? Return empty array. Okay, vector. Okay, so basically, okay, so the first approach that basically comes in my mind is that if we can use some kind of recursive traversal, right? Okay, so let's say I am at 5. Since okay, so I will just call a DFS. I'll go to 4, then I'll go to 11, then I'll go to 7, right? Okay, so 5 4 is 9, 9 11 20, 27 27, right? But it is 27, which means that obviously it is greater, so I can't move to this path. So I'll track back, so I'll be 11, which is I'll be with 22, then I'll go to right. Since I go to right and it's equal to 22 and it is also the leaf node, which basically means that I should add this in my answer, right? And there is one more thing which basically is that we must keep track of the things, right? We are from 5, then we went to 4, then 11, so we must somehow keep track of this. We can use global variable, or we can also pass this by reference. And after that, what we can do is that, let's say I have something like in my um, result, I will have something like this. Okay, I'll have 5 4 11, and I'll have 7, right? So because we know that 7 is incorrect, so obviously I'll have to remove 7 and I'll go to here, okay, which is obviously 5 4 11, and from 11 I'll go to 2, and now this is my desired result, so I'll just push back. Okay, so basically we have to backtrack, removing this thing, right? And one more thing which we have to do is that we have to maintain something known as uh, sum, right? We can say current sum, okay, which will basically holds the current sum. Okay, current total sum, I can say, right? Okay, so basically I guess, yeah, so we will basically call a recursive function and we will maintain these variables. Okay, so since we have a root and we have a target sum. Obviously, instead of that, we can do something is that we can reduce the target sum from here, right? I guess if we will do in that way, we don't have to maintain this extra variable. So let's say okay, we'll have a base case, and we'll say okay, firstly we will say okay, so we'll go to left, right? So I'll say okay, okay, so basically we have to return an answer, right? Okay, so if we try to do it in this way, possibly it wouldn't be great. So instead of that, let's write a function. Okay, let's say void, let's call it get path, and I'll have this is my root, and I'll have my int, let's call it current sum. Yeah, and yeah, this should be it. And I will also have one in, let's declare a variable, let's call it vector of int, and let's call it answer. And one more thing, we also need to maintain something called as path, which is vector of int, let's call it result. Okay, and let's pass it by reference. Okay, and okay, so initially I'll just insert this element, which is root, what is it, root value, right? Okay, so I'll have to traverse left and I'll have to traverse right. Okay, so if I am going to left, okay, so if I am going to left, I'll say okay, so now I'll just say it as target. Yeah, so my target sum will be reduced, right? So my target sum minus equals to whatever the current sum is, which is root value. And obviously if somehow my target sum is less than 0, we must do something. Okay, I'll take care about this later. Okay, so basically I'll do one thing, I'll firstly go on to left and I'll go on to right. Okay, so I'll just call this I'll say okay, go on to left, and my target sum is okay, let's call it new target sum, and I'll pass this result. Okay, and I'll have one more thing, which is it will be yeah, okay, and after calling this function I'll just call it for right. Okay, yeah, so I called it for right. Okay, so basically from root I'll go to 4, then I'll go to 11, then I'll go to 7. Okay, once I have a situation that okay, so I'll have some base case. Base case is that obviously base case will be if whatever the target sum is less than 0, obviously then I'll have to return. Okay, so basically I'll have to return, right? So before returning I'll have to backtrack. So I'll say in the result dot, I'll just pop back. Okay, and yeah, that should be it, right? Yeah, Okay, that's it, right? So I'll say okay 11, I reached a point, so I'll have something like 5 4 11 in my array. So I'll in my this result vector. Then once I go to 7, I now know that my okay, still my target sum is not less than 0, right? Yeah, so I'll have 7 as well. Now I'll again call 7, so I'll again call left, or I may call right, I don't know, I may call left. So when I call left, I'll see that my target is now basically negative, right? Because I have 549 plus 11 is 20 and my target is 22, so I'll just subtract 7 also, right? So yeah, I'll pop back. Okay, now yeah, I guess yeah, it's correct, and we have to just deal with the case when we basically have a leaf node, right? So I'll basically say if target equals to 0, and obviously basically we don't have a node, right? Basically root is null, and root is null. In that case, basically means that I 5 4 11 2, from 2 I reached left and I reached right. Obviously this will, but this will basically cause printing 2 times. So instead of that, I'll say if target equals to 0, okay, I'll just put it here, okay. Because okay, I don't want it to be repeated 2 times, so I'll say if target equals to okay, my bad, yeah, if I'll say okay, yeah, let's set if target equals to root val, and root left is null, and basically I can say root right is null. Both are the cases, which means that this is, so I'll just say answer dot push back. I'll just push this result, right? Yeah, this should be it. Otherwise I'll just move on, right? I'll just push back. I'll have my new target sum, and obviously I'll just move on. So my bad, so I'll have to do something like and I'll have to just return, right? Okay, my bad, I'll have to write it here, obviously, because I want this value to be in my result, right? Okay, I'll just have to write one more thing, which is result dot pop back. Yeah, I guess it should work. Okay, so obviously if it is null, then obviously I should return, right? I should return. So I'll basically call this function, which is get path. I'll just pass on the root, I'll just pass on the target sum, I'll just pass on the result. I'll just create a vector of int, let's call it result. Okay, and I'll basically return the global variable. Let's try to run this. Okay, what is the bug? Okay, if target, okay, target sum, right? Yeah, I know it's not a clean code, but yeah, let's try to check. Okay, okay, my bad. Yeah, in edge cases we are missing, obviously. If it is null, then obviously it will return null, right? Yeah, so get path, my bad. Yeah, okay, so it's accepted. Let's try to use the example test cases. Okay, now let's try to submit it. Okay, I have a wrong answer. So okay, let's see, what did we miss? Okay, so we have something like -2. Okay, what is the 3? Okay, it's something like -2 -3, and the target sum is -5, right? Okay, the sum is -5. Okay, so I returned. Okay, if target sum is okay, yeah, the target sum can be negative, right? Yeah, so obviously there can be a case, so I'll just have to remove this. Let's try to run the code. Yeah, so run the code. Obviously I should, before jumping on the solution, I should clear up that, that the numbers can be negative as well. Yeah, that is kind of not a good sign, I guess, for the interviewer as well. Okay, yeah, so it's working, right? Okay, so it's working fine, I guess. Okay, but what we can, if we try to modularize it, what we can improve? Obviously it looks fine, right? And somehow we'll reach target sum. Okay, I can do one thing, is that instead of having to go through with this, I'll say, okay, I don't know, I guess this is necessary, right? How will I know that I have reached a leaf node? Is that I'll have to check this, right? Yeah, and if I want to ignore this, so I'll go from 5 4 11 2. Then from 2 I'll call a null node, and now my root is a null node, so I'll have to check, right? So again it will call right null as well. So in that case, obviously I can do one thing, is that instead of writing this all things, right, maybe maybe let's see if we can improve. Okay, 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 let's see if it is null, right? Root left is null, then yeah, let's leave it. I guess it should be working fine. Yeah, one thing is that obviously we can pass on this answer variable here, so that we can basically try to modularize it. I guess the namings are fine. Okay, yeah, so I'll see you on the next problem.